Hey, my name is Charles here at JTech, and we're going to go over how to read a schematic using the Snap-on Mitchell's program. We're going to go over the basics of a legend and then a basic circuit. So when you start reading schematics, you kind of have to know what you're looking at. This is called a schematic legend. This is just from the internet. It has things like coaxial cables, shielded wire. Not every schematic will have these pieces on them, and not every schematic will use like a coaxial cable or a shielded wire. It may have a different symbol, but this is general how, like, transistors are the same, diodes are about the same, motors are about the same, batteries are about the same. But this is one you can get from the internet. As you can see, there's different ways of looking at it. You know, here's it. So here one that says heating element, which is just a resistor, but it also has or this. So it depends on what you're looking at. Like this is a connector, but in Mitchell's you'll see arrows everywhere or a little hashing, and we'll go over that. So this is just some basic stuff. This is a basic schematic. If you look, so we've got like grounds, headlights, this is a bulb, relays. If you looked on here, on this, we got the ground. So these are symbols. These are just wires that, on this schematic particularly, this is just a headlight schematic. We've got red to mean like power side, and we've got black to mean ground side. So this is just a simple wiring diagram, and we'll go through Mitchell's here, and you can see that. So forgive me for shooting a screen, but this is the best way to do this. Now on Mitchell's, they have how to read their wiring diagrams, and every wiring diagram or program will have a legend on how to read the pieces within their wiring schematics and circuits. So if you look, we got boxes, batteries, boxes, connectors. See how these connectors are different than the ones that were on the sheet I showed you, which was actually like a 2 parallel lines. So you got the 2 parallel lines for, oh, that's a capacitor, excuse me. So, but this capacitor is actually, it shows the direction that the capacitor is going. Got connectors, diodes, fuses. Diodes are about the same no matter what diagram you're on. Transistors look similar. These are switches, motors, potentiometers, photocells. So this is how to read the specific things on the wiring schematic. Relays, alternators. So if you ever have a question when you're reading a diagram, you can always check the legend, which is what this is called. This is called a legend. This just happens to be separate from the actual wiring diagram itself. So let's go look at a horn schematic for this international, and we'll see where these pieces are. So here is an actual horn circuit. This is the wiring diagram for the horn circuit. Now if you look, I don't know if you read it on the other page, but like this box right here has got dotted lines around it. What that means is that that's not all that's in that box. It means there's a lot more to it. See, like this box right here is a solid box. That means that that's all that is in that box. There's nothing else in it. Here's an interesting symbol right here. It's a clock spring. You got clock springs connected to horn switches. Makes you wonder why you have those, huh? Okay, we've got a air horn. It's in a closed box, but look, we've got the air solenoid ground adapter, which is in a dotted box, which means there's more in that box than there is in that box. So it's interesting to read these things. If you look, we've got gray. That's the color of the wires, and here's the connectors. See the little connectors that was on the diagram. We've got a ground. We've got another connector inside of this. Now look, this is the body control module right here, and it's dotted, which means that's not all that's in that box. But yet below it we have a horn switch. That's all that's in that switch. This looks like it's a diode, but what type of diode is? Let's find out on our schematic legend. Let's go back. What kind of diode is that? Let's see here. It's just a diode of some sort. That's an LED. Look at that. So it's a diode symbol, but with an LED. So this horn switch has an LED in it. There's a switch right there. We've got interior light systems, so these lines go to the interior light system. It has a white and a dark blue coming out of this line. That completes this circuit. If you follow this, it goes up to a connector that is shared between the air horn switch and the clock spring with an air horn switch. So that's just a connector to the body control module. So it's interesting how they read these schematics. They connect to the disc horn, electric horn. It's just simple schematics. Again, this is a complete circuit. So if you look inside this horn, it's got this funky symbol in there. Well, what's that symbol mean in there? Well, it's a coil. And how do we know that? We can go back to our schematic and look at that. There's that loop-de-loop right there, and it's a coil. So that's generally how you read schematics. It's not difficult, but it can be kind of confusing. It's more like reading a road map. It's from A to B, so if you have a problem in a circuit, you can check each piece of the circuit. We can isolate the switch, we can isolate the clocks, we can isolate the body control module, we can isolate the switch. So there's a little, this is just a way of looking at it visually, looking at the wires without trying to look at the mass of wire harnesses that are inside vehicles. So I hope this is helpful. Now we're going to talk about electrical relay. Relays are really good in vehicles because it allows a low current to be maintained, high current to be maintained at one point, but it doesn't energize the circuit, so it won't overload the circuit. And it uses a low current to actually access that high current. I know it sounds difficult, but it's really a lot easier than it is. So if you come, look at these relays. This is a relay box inside the engine compartment of this, what is it, Dodge? Chevy. Inside this Chevy. We're just going to pull one of these relays. So this electrical relay, if you can read on here, I don't know if you can see it, but it says 30, 85, it says 86, and 87. It's just showing how the actual relay works. It'll be 85 to 86 will be your coil, and from 30 to 87 will be your actual switch. If you look on most relays, it has a little diagram on the outside of it. You see that? What we're gonna do, we have a relay over here that's been taken apart. This is what's inside your electrical relay. So again, here's your pins. This one's black on the bottom instead of white. And this shows a fifth pin here in the middle. But again, you got your 30, 80, 86, 85, and 87. So here's your coil in this way, if you look at this. And here's your switch. So if you look, this is what it looks like on the inside. You got a coil. Alright, and with the multimeter, we can actually test this thing. So we're going to put just the volts. We should be able to get, ohms. We should get resistance in the, let's see, where's 30? There should be an open resistance between 30 and 87. We should get open because our switch is open. And it's open. Now we should get an actual actuation. We actually have, so here's our switch. And it's not enough voltage. But if you look, it does show resistance on the coil side. So we do have a working relay. 87.5 ohms, that's our resistance on our coil. So it's just interesting, we got our resistor here to show the resistance within it. And if you look on the casing that comes with this relay, if you look, it's got the coil, but it also shows a resistor on the outside of that coil. Here we go, there's the resistor, there's our makeup. So there's our coil with the resistor, and here's our switch. So that turns our low power side, which is 85 to 86, which is our controller, creates electric magnetism, which pulls over our switch on 30 to allow high voltage to go through the switch here or the relay. So it's a simple makeup of it. This allows so that if the voltage is too much, it'll blow the resistor, so that it can actually blow the circuit, help protect the ECM a little bit. I hope that was informative. I hope you learned something. Thanks, and have a nice day.